First we are going to see Markov process. Markov process or Markov chain. Markov process first. A Markov process is a random process or stochastic process. The future state is only dependent on the present state and independent on the past state. It is a continuous time process. That means Markov process is dependent on the present state, not in the past. So if you want to check whether it is going to rain now or not, you have to check what is the climate 1 hour before, that is the present, not 1 year, that is the past. So this process is the Markov process. This is on the continuous time process. Time is continuous in the interval. Only the present state influences the next future state. If in a process the future behavior depends on the present value but not on the past, then the process is called Markov process. A random process x of t is said to be Markov process if probability of x tn, which is equal to an, conditional probability given that x of tn minus 1 equal to an minus 1, comma x of tn minus 2 equal to an minus 2, etc., etc., x of t1 equal to a1. That is a continuous process, is from the state a1, a2, a3, etc., etc., up to an. That is future state. An is the future state and present state is an minus 1, and past states are an minus 2, an minus 3, etc., etc., an, which is equal to probability of x tn, which is equal to an, conditional probability given that x tn minus 1, which is equal to an minus 1. That is the future state an depends only on the present state an minus 1 for all t1, t2, etc., etc., or t1 less than t2, etc., etc., less than or equal to tn. Some examples. Say I already told you the same example. The probability of raining today depends on previous weather conditions existed for the last 2 days and not on the past weather condition. Correct? And next one, predicting the stock prices. Stock prices in the stock market, we are checking the stock prices daily basis, on the daily basis. So today's stock price depend on the yesterday's price, not last year or 1 month before, right? So that is a Markov process. Next, consider any board game. In a board game with the dice, so you are rolling the die, then you have to move the coin. So this movement, that is the movement of the coin with respect to present number in the die, not the past. So consider any board game played with dice. The next state of the game of players depends only on the current state in which what is the outcome of the dice. It does not depend on how the state of game in the past. So these are all the Markov process. Next, Markov chain. Markov chain definition. So in this definition, a Markov chain is a discrete time process. So what we saw in Markov process, a Markov process is a continuous time process. Correct? A Markov chain is a discrete time process for which the future behaviors given the past and present only depends on the present and not on the past. The same Markov process and Markov chain are same, but process means it depends on the continuous interval and chain means it depends on the discrete interval t1, t2, t3. That is in between t1 open interval or closed interval t1 to tn, that is Markov process. A Markov process is called a Markov chain if the state space is discrete. Discrete means it should be finite or countable set, right? The space is finite or countable. A Markov process is a continuous time version of Markov chain. That is, if probability of xn which is equal to an, given that xn n minus 1 equal to an minus 1 etc etc, x naught equal to a naught, which is nothing but probability of xn equal to an, given that xn minus 1 equal to an minus 1 for all n, then the process xn is called Markov chain. A1, A2 etc etc an are the states of the Markov chain. So examples, a model of traffic light. In traffic light you have three colors, right? Green, yellow or red. So this is discrete, it's separate, right? So in this case, if it is green, car will go or traffic will move. Red, if it is red, the traffic will stop. If it is yellow, it is an alert for changing red to green or green to yellow, right? So model of a traffic light with three states, only three states, discrete, right, which is a separate one, and transition directed by the rules of the traffic lights. And second example, a model of a spread of virus through the population. So if it is spreading some virus is spreading, we know the state of Markov chain represents the number of people who have been infected at any given time, and the transition between the states are directed by the rate of infection and the rate of recovery. So we know COVID. So how it was spread. So today what is the total number of people affected by the COVID, and tomorrow what is the numbers, and what is the recovery, this is the rate of change. So next day, that day, so it is like a discrete time interval process, and this is a Markov chain. Next, transition probability definition. The probability of moving from one state of a system into another state is called transition probability. That is, moving from one state to another state. That is what? Red to green, green to yellow, yellow to red, right? So today, what is the number of population affected by the virus with respect to how many recovered from that? That is the ratio. So what is the tomorrow's one? These are all the state. So this particular fraction or the probability value is called the transition probability, one step transition probability. The one step transition probability is the probability of transitioning from one state to another state in a single step. Single step means red to green, single step, green to yellow, single step, like that. The conditional transition probability of xn equal to aj, given that xn minus 1 equal to ai, is called one step transition probability from the state ai to aj at nth step, nth trial, right? And is denoted by Pij n minus 1 comma n. Next, homogeneous Markov chain. A homogeneous Markov chain is a Markov chain whose probability of transitioning is independent of time. The transition is independent of the time. So that is, the probability of transitioning from state ai to aj at time tn is the same as the probability of transitioning from state ai to aj at time t1. So for example, just I am giving an example, the spreading COVID. Suppose Yesterday was 100% affected. The next day it will be 300, right? So the other next day, next, and after that the affected person will be 300 into 300, 900. So every time per 100 it is increasing 3 times, right? So it is not depend on time, it is depend on the number of counts. That is called homogeneous Markov chain. If one step transition probability does not depend on the step Pij n minus 1 comma n, which is equal to Pij m minus 1 comma m, the Markov chain is called homogeneous Markov chain. If one step transition probabilities are independent of the step, the Markov chain is called homogeneous Markov chain. Next, transition probability matrix, it is called TPM. A transition matrix or stochastic or probabilistic matrix is a square matrix, n by n matrix, representing the probabilities of transitioning from one state to another state in a single unit time. It denoted by P is equal to P11 position, 1 1 1 2 1 3 are positions in the matrix, P1n etc Pnn, where each element Pij gives the probability of moving from the state I to j in one time step and satisfying the following conditions: all Pij greater than or equal to 0 because all are probability, and summation of Pij equal to 1, that is P11 plus P12 etc Pnn equal to P11 P12 plus etc P1n equal to 1 for each row elements, right? The sum of the elements of any row in TPM equal to 1, that is first row. Second row summation P21 plus P22 plus etc Ptn equal to 1, like that. Example, the 3 boys A, B, C are throwing a ball to each other. A always throws the ball to B and B always throws the ball to C, and C is just like to throw the ball to A as to B. So we will see the TPM of this Markov chain. P is equal to, here first ABC in row ABC. So first A to A is not throwing to ball to himself, not throwing ball to himself, so the probability is 0. A to B, A always throw the balls to B, so probability 1. Next A to C, A is not throwing ball to C, so 0. Next B to A, B is not throwing ball to A, 0. B is not throwing ball to B himself, so 0. B is throwing ball to C, so 1 probability. Next C is just likes to throw the ball B as to A, either B or A. So C to A the chance is half, and C to B the chance is half, and C to C 0. That is called transition probability. So we'll continue with the next part. Thanks.